Hello everyone, namaste to you all. I am very much indebted for your gracious presence. Professor Omnath Paurel, my supervisor Basantagiri sir, respected external sir, and all my dear friends. I am Raju Sharma Khatioda, and this is the topic of my presentation, surface tension correction in the precession of the perihelion of Mercury. Okay, so let me briefly tell you about the outline of my paper. So first I will talk about the introduction. In this introduction I will not just talk about the precession of the perihelion of Mercury, but I will talk about the theoretical framework under which this is based, and then we will talk about the literature review, about what works I have used to conduct the research of my own. Methodology is all about the mathematical calculation, where I modified the line element to get the appropriate correction for the surface tension, and results in discussion, comparison between theory and observation, and conclusion and future prospects, references and acknowledgements. Now let me talk about the precession of the perihelion of Mercury. In any solar system, if we talk in reference to our solar system, then one of the fundamental mistake we do is we think that the earth revolves around the sun, but that is not true, because the earth and the sun, they revolve around their common center of mass. That is true for any solar system. So since the perihelion shift is inversely proportional to the square of the time period, the perihelion shift is not, the precession of the perihelion is not significant for other planets, because as you know they are further away from the sun. That's why their period is more, and the perihelion shift becomes very much less. That's why it only makes sense to talk about the precession of the perihelion shift for the Mercury planet. And now let me talk about the other problems which I believe are related to this problem. So first I will talk about the solar limb effect. Solar limb effect is the phenomenon of the wavelength shift of the certain lines in the solar limb. Now let me talk what that is, because generally we interpret redshift as the effect of the expansion of the universe. There are certain lines known as the Fraunhofer lines which are observed in the solar limb, and they are seen to be redshifted, but there is no valid explanation for that. And the second is the coronal heating problem. This is also one of the major challenges for the current astrophysics, because as you know the corona is farther away from the photosphere, right? So if something is farther away, the temperature of that has to be less. That is common sense, but that is not true, because the temperature of corona is between 1 million to 8 million, and the temperature of photosphere, as we know, is only 6000 Kelvin. So we will talk about this, because we believe that all of these problems are related together, and this paper, the precession of the perihelion of Mercury, is based on a framework which I will try to address, and I believe that that framework will be able to explain these paradoxes as well. And there is the Pioneer 6 anomaly. So Pioneer 6 anomaly is nothing but the data sent by the Pioneer 6 spacecraft that was also found to be redshifted, but because of the carelessness of a scientist called Goldstein, that was not accounted. So we believe all of this fall under the same framework. I will come to that later on. Now let me talk about the literature review. Let me explain what this surface energy is. Now we can understand this surface energy in three ways. The first is the gravitational analog of Compton scattering. Now I don't know if it is correct to call this a scattering process, because I don't know if there is an actual collision, but we know that photon has momentum because it is a particle. So if we consider, we generally for convenience we say that there is empty space, but when we look at the absorption line, then we see that there is the presence of calcium ion and sodium atoms, right? So when photons are also particles, so photons might collide with those particles, and because of that collision it will transfer the momentum, and there is the significant loss of energy, and that means frequency shift, and so the corresponding wavelength shift. So it can be understood in that way. The Compton scattering, like some of you might think that this is Compton scattering, but it is not actually Compton scattering, because Compton scattering makes sense only for one electron and one photon, but we are talking about many photons and many electrons, so it will be smeared in all the directions, making it useless. So we are not talking about any type of scattering, we are talking about gravitational scattering, we can say, or maybe this is a new phenomenon. Somebody better will come and coin a better word for it, but for now this is the gravitational analog of Compton scattering, but I do not know if this is scattering at all. So another way to understand this is the surface tension under gravitational potential. For example, at the molecular level we understand the surface tension as the effect under the van der Waals potential, but we know that gravity is a weak force, so it is significant for a longer distance, and we can think of something as analogous to the surface tension, but that is due to the gravitational potential and not the van der Waals potential, because for the longer distance only the gravity is significant because it is a weak force. And now the other is the gravitational friction. This is the work done by a scientist Zwicky in 1929, and the picture is like this. So you can understand the work done against surface tension as a type of a differential. So there are three viewpoints, and now I want to take you to the Zwicky's comment. If you read here, like, it is therefore desirable in the first place to place the computations on a sound theoretical basis involving the general theory of relativity. So Zwicky was also trying to modify the general theory of relativity because he believed that this was a significant phenomenon, but he couldn't do that. So our work is an extension of Zwicky's in that sense. So I use the modified Friedman equation. This work is done by my supervisor Carlos Ortiz. Okay, you might wonder how we arrived at this modified Friedman equation. This is just sum of all the energies, kinetic energy, potential energy plus surface tension correction. So we got the modified Friedman equation. From the modified Friedman equation, I use the redshift equation. There are multiple expressions for redshift, and like the one I used is 1 plus g is equal to 1 by root under 1 minus b square by c square, and that b square is the escape velocity. So v square would be equal to 2gm by r. So using that, I got the metric, and that's how we modified the line element. Okay, now from here the mathematical part begins. Now because we are talking about a type of surface force, so it makes sense to talk about the path. So that's why we are talking about the line element, because only through the line element we can modify the general relativity. So this is just the extra term, everything else is the same. This is just the extra term that is added because of the surface forces. Now we get the Lagrangian from that line element, which is like half mv square. There is complicated mathematics which I have done in the Termpaper, and from the Lagrangian we arrive at Hamiltonian using the laws of classical mechanics, and these are the dynamics of the system using Paschen bracket. I use all of this, and as you can see that the third one, this is equal to 0 and this is also equal to 0. So it means that this is equal to some constant. I equated that to alpha and the other to L, and then I use that in the other expression, and then I finally got this expression. And then again, using the values from this dynamics, I substituted the value of this one, generalized momentum, with respect to coordinate r, and then I got that. And then from there, okay, now this was problem because the equation was getting very complicated, and it doesn't mean anything if we cannot solve the equation. So I changed the variable from r to 1 by u, which is the standard procedure, hoping that I would reach to something called Binet equation. So this is the standard Binet equation, right? But in place of that, I got this equation because ours was with correction. Now it was a big challenge to solve that equation. After lots and lots of effort, we were actually able to solve equation 11 by using the method of multiple scales. So these are the things I input in that equation, in equation 11, and then I got this equation, equation 12. Now the challenge was to solve this equation 12. I solved this by parts using different orders. So there were 4 equations again, and then I solved each of them individually, and then finally we got the expression for u, because this is what the equation is all about. So this was the extra term that was contributed from the surface forces. Thankfully this is linear, so we could make sense of this. And then, okay, now before going to results, I would like to talk about this table. So this is adapted from the Wikipedia. So different sources of the precession of the perihelion of Mercury. Since what we are doing is we are actually modifying the laws of general relativity to actually account for the surface forces. So what about the differences between observed and theory that was predicted by GR? We believed, at least as of now, that was accounted by the surface forces. That's why this was the observed value. This was the observed value, and we believe that this has to be the cumulative effect of general relativity including surface forces. And okay, so we were able to reproduce this result for general relativity, which is 42.95 seconds per century, and then the difference, as I already talked about, this was to be accounted by the surface tension. Now there is something important to talk about here. Solar density is something that is very vague. We do not have a concrete value for that. So we relied, rather than relying on some value that was not concrete and correct, what I did was we input this delta phi st into the equation to actually constant the value of density, so that we could compare that density which we get from the theory to the actual observed to see if it made sense or not. And then we got the value of density at the solar corona to be 3.43 into 10 to the power minus 15 kg/meter cube. But it could have been done the other way also. I could have input the density and then got that, but since we do not have a complete understanding of the density of the solar corona, I did the opposite. And this is the observation. As you can see, let me zoom in, let me try to zoom in. Around this one, this is the outer corona region, which is at a distance of 18,000 kilometers from the sun. As you can see, the density is 10 to the power minus 18 gram per centimeter cube. So if you convert the unit, then you will in fact get 10 to the power minus 15. So we are very much optimistic that we got the correct one. Now this is the comparison. So this is only for few revolutions, right? But we are talking about revolutions for a century, for even tens of millions of years, right? But this is only the simulation. This is done using Mathematica. But we do not see a significant difference. This is only general relativity, that is general relativity with surface tension correction. I have explained here why it is so, because we know that it is a very small effect. But the thing is, if you look at this table, then there is such a small effect that is accounted. But ours effect is the magnitude of that effect is more than this one. That's why I am optimistic that we should include this. Okay, so conclusion and future prospect. So like what we have done in this paper is just application of the framework, but we are after the bigger thing, that is developing the framework itself to actually account for many unexplained things that are challenging the current astrophysics. And the problems include the solar Lindh effect, the coronal heating problem. Actually we are also solving the coronal heating problem. We have already derived the equation, but we are having some numerical inconsistencies. That's why our work is pending. And yeah, these are the references I took and acknowledgements. I am very much indebted to my supervisor, Professor Dr. Carlos Ortiz, whose work I depended upon and who I had amazing discussions with to actually develop this work. I am very much thankful to my another supervisor, Basanta Giri sir, for his support and facilitation during the work. I am very much indebted to our teaching faculties of Golden Gate International College, especially Professor Omnath Paudel and all of my dear friends. Thank you so much. Yes, sir.
Thank you, Raju. Your surface tension correction. Did you make any estimate of how much is the value for the surface tension correction?
Yes. We need to input the value of density to get that, right? But I look at the literature and I could not find any, like most of them, they depend upon the solar coronagraph to actually get the data from the sun. But that itself is not very much valid, because if you look at the problem of the coronal heating problem, then the temperature is 1 million at one point, and there is even for a little distance there is 8 million. So there is not a consistency, and we know that temperature depends upon density. So because of the lack of the actual value of density that we could not have, like it was not made by anyone, so that's why we did the other way around.
So okay, otherwise it looks really nice, and I'm not as sharp as in mathematics as you are, I guess, yes. So perhaps, so for me it looks good. I don't know, say home, so I have
सर त्यो त धेरै कम्प्लिकेटेड, त्यसलाई यस्तो गरे सर, हेर्नु जस्तो म एउटा देखाइदिन्छु। 6 महिना हजुर, जस्तो अब फर्स्ट इक्वेसन यो अर्डरको इक्वेसन भनेको त अब सेकेन्ड अर्डर डिफरेन्शियल इक्वेसन भयो, नन होमोजिनियस भयो 1 को कारणले गर्दाखेरि। सो त्यही एक्सपोनेन्शियल y = a times e to the power ibx प्लस गरेरै गरियो, अनि त्यसको करेक्सनलाई फेरि अब अर्को यो सेकेन्ड अर्डरको इक्वेसनमा एड गर्दै गर्दै फाइनल्ली एउटा एक्सप्रेसन आएको छ। यसमा त्यो र यो चाहिँ इजिली सल्भ भयो, तर यिनीहरूलाई सल्भ गर्न चाहिँ त क्वान्टर इन्टिग्रेसन लगाउनु पर्यो।
अनि यस्तो चाहिँ तिमीहरूको चाहिँ तिम्रो यो एनालिटिक सल्युसन करेक्ट छ कि छैन भनेर चेक गर्नु लागि तिमीहरूले चाहिँ जस्तै अब यो एक्सिलियरी इक्वेसनहरू लिएर चाहिँ इक्वेसनहरू सल्भ गर्छौ, त्यो भयो होइन, तर तिमीहरूले चाहिँ न्युमेरिकली पनि यहाँबाट सल्भ गरेर फाइनली चेक गर्ने तिमीले एनालिटिकली जुन सोल्युसन निकालेको छ त्यसमा पनि तिनै नम्बरहरू लिएर चाहिँ चेक गर्दाखेरि त हाउ करेक्ट आइएम अथवा त्यो भन्ने चिज थाहा
होइन, हाम्रो एक्युरेट सोल्युसन नै आएको छ त्यसमा।
Some assumptions that you are using which really are not applicable.
Yes.
The solution त्यो चाहिँ जस्तै एग्रिमेन्ट मतलब त्यो हो
हजुर
त्यस्तो गर्दाखेरि न्युमेरिकली सल्भ गरेर पनि
हजुर
सल्युसनको लास्टमा पनि त्यही नम्बरहरू प्लग इन गर्दाखेरि
थाहा हुन्थ्यो हजुर हजुर होस् सर त्यो चाहिँ गर्न सकिन्छ टु बी मोर कन्फिडेन्ट अबाउट द थ्योरिटिकल एस्पेक्ट अफ द वर्क वी कुड हेभ डन द्याट यस